Hello everyone. Mm, I am Madhur from Engineering Physics third year. I'll be giving my presentation on image scaling. So let's get started. As we all know, digital image are part of our daily lives. People can hardly live without it. Therefore, digital image processing becomes more and more important these days. How to increase the resolution of images or how to reduce noises of images are always hot topics. Fourier transform can help us out. We can utilize Fourier transformation to transform our image formation to grayscale to frequencies, and we can manipulate these frequencies. So, in the table of contents, we'll be discussing about applications. I'll begin with one example, then I'll walk through the code of that example. After that, we'll study the theory behind it and another example with more fundamental code for it. So, the desired case for this example would be if I would have converted a video of 1080 pixels to 4K pixels. But due to limitations of machinery, I'll be making two compromises. That is, instead of rendering the whole video, I'll be only covering the boundaries of the figures in that video, and instead of the whole frames, I'll be taking one or two frames for it because, as we'll see in the code, it takes around 30 to 35 seconds for one frame. So I'll show you the code now. I'll delete these two images. So what this code does is, if I'll give three videos to it, that is a alpha video, a colored video, and the original one. I'll show you each of the videos. This is the alpha video. Since we are only doing for the boundaries, we have to create this video. Then a color video in which the background and the figure are easily distinguished, and then the original video from which we have extracted both of these two videos. I'll show you that too. This one. So I'll go through the code in a while. So let's run this. We'll have to wait for around 30 seconds for both of the images to render. So initially I'm showing the screenshot of the first frame. This is the first frame and this is the original one. Now we'll wait for the scaled one. And we just have to notice here that first of the things shows here is 1080 pixel into 920, and another size of the matrix is 2160 into 3840. I'll show you what it is. And the scaled one is this. So looking closely, this was the original image, how it had looked, and this is the scaled one after processing. So as we can see here, there is clearly very much difference in both of these two frames. Now I'll give a walk through the code. What we're doing is we are reading all the three videos here using a library called OpenCV. So we done that. Now I'll read frames from the video. Like here we can see this is alpha, this is for color, and this is for original. Now after reading, as I showed you before, that the screenshot of the first frame of original, I have write it down like this. Then I'm converting the frames to grayscale, and after that I'm using a threshold that if any color pixel value, the RGB values are below 150, give it the value of 0, and about 255 give it a value of 1. Then I'll create a contour matrix. I have the contour matrix for the alpha video, and then I'll write the image on another matrix having the size of alpha. So this is an empty array. We initially initiated an empty array with the size of alpha frame, and then we are drawing the contours into that array. After that, we'll be iterating through the array we just saw, which is not empty anymore. We'll be iterating through both of that, and if the value of the black black value of the pixel is greater than 254, I'll give the whole RGB value to 111. So With this piece of code, what it is doing is, in the matrix we only have zeros and ones now. Ones are the pixels having one value are only the boundaries, and other than that they have zeros. So I'll take this value and I'll multiply it with the color video. We just saw the color video. So after multiplying it with this, and I'll have it in my answer. So this answer matrix contains the product of the color video product with the boundary video. So what this matrix is, I have a set of pixels of only boundaries, but this time they are not ones all, they're colored, which were in the colored video. So now I'll scale those pixels, and after scaling these pixels, um, as I told you that there was a value printed 1920 into 1080 and then 3840 into 160. So yeah, this was the print statement here. Okay, initially it was 1920 and then it is 3840. After that, I'll replace the pixels of my original video with the scaled ones, and I had shown the output. This is the output. That this was the output, and this was what we began with. So this was the theory behind. This was the code behind all that. Now let's deep dive into the theory. Among many methods, Fourier transformation for scaling of images is the best one. So let's see what happens. Well, we saw what we done with. What happens really is we take an image, we'll convert it to grayscale, and then we manipulate the frequency distribution. So I'll read the steps here. Transforming our images into Fourier representation, that is 2D frequency. So what we do is, from the spatial domain to we convert the image to frequency domain. Then for upscaling and downscaling, we add zeros or remove lines and columns respectively, and then we'll undo the Fourier transformation and go back to the space domain. And that was how our image was scaled. Now mathematically, a two-dimensional image Fourier transformation is this figure, where f is the image value in the spatial domain and capital F for the frequency domain. Now I'll be going with example number 2, where in this example we will be saying that if I have a pixel value, let's say I have an image of n cross m size, and I have to scale it by k times, then how does it really happen with the code? I'll show you in MATLAB. This is the MATLAB code. Say I have to double it. So what I have done is I have double it, and then what we do is we implement interpolation by integer. Like this time, k value the value of k is 2 in the frequency domain. Then we'll enlarge the n cross m point of the FFT of the original image into k times n cross k times m. So if the image pixel value is 10 cross 20 and we have the value of k2, then it will be 20 cross 40. Now I'll add the zero padding to the original FFT in the frequency domain except the corners. So that is how we can do image scaling by Fourier transformation. Thank you.